I can't release them back to you because there's still one person from this class who has yet to take it, so I don't want to release it back and you give it to that person. So I'm just holding it tight until that person takes it, then I'll release it to you. I love the results on the quiz. Love them, and not because there was a high average either. I think it was a high average, but that's not why I really like the grades. I really like the grades because we are getting to the point in this class, the point in the year where the amount of time you put in, the amount of effort you put into class really relates to the quiz grade you get. All right, because I know there's a ton of you in this class that bust your tail for me, and I appreciate that. You did really, really, really well on the quiz. And then there were some last week who kind of took it off because we were remote or got lazy on me for some reason, and it got reflected in your quiz grade. All right, and I know that this sounds mean, but I love it. All right, I love it when hard work pays off and laziness does not. So that's the point we're getting to in the year right now in this course, where the more effort you put in, the better off you are. All right, so that's the deal with the quiz. Test will be after break. If we are back in the hybrid mode, it'll be Thursday, Friday. All right, I think I said Wednesday, Thursday originally to you, but we are, because of the snow day, we're pushed back a day, so it's going to be Thursday, Friday of the week we get back. We didn't have any homework over the weekend. Nice. That was nice. No homework over the weekend. So I thought it would be a good time right now to discuss your options for next year as far as a math class goes. Because believe it or not, when you guys come back from break, you're going to virtually meet with your guidance counselors and pick your courses for next year already. So I wanted to go over your options for next year. So up on your screen right now, I have the pathway for an honors level kid. All right, typical pathway for an honors level student. And I realize there's 10th graders taking this course right now, and I'll talk about you guys in a second. So right now, you guys know we're in honors geometry BC. All right, we're right here. There's two paths you could take next year. You could continue in honors BC, or you could go to Algebra 2 AB, and I'll talk about both those courses in a minute. And then as you guys could see, when you get to your junior year, you're going to take some level of pre-calc. And then your senior year, if you choose, it's not required, but if you choose your senior year to take some level of calculus. You know, you also have AP Stats out there as well and some other courses you could take if you didn't want to take calculus. But this is basically the progression of an honors level student in 9th grade. And yes, along the way, there's always a lot of students, and it's not a bad thing at all. Along the way, whether it be next year, your junior year, where you end up on the AB track and get out of BC because, hey, it's just too darn hard. All right. I don't know any numbers, but I would think that there's probably, if I teach, let's say 90 honors students in 9th grade, by the time they hit senior year, maybe 30 out of those 90 end up in Calc BC. Somewhere along the way, they just end up in the AB track because it gets too hard. Okay, so that's the track. Now, what are your options for next year? You only have two options. There's also computer science, which I'll talk about after break, but you have to take Algebra 2 next year. All right, some version of Algebra 2. There's Honors Algebra 2 BC, and then there's Algebra 2 AB. So let me talk about the two courses and then answer any questions that you have. First, with the honors level. This is real deal honors. All right, this is a step above me. Okay, this is real deal honors level. In 8th grade, and maybe even this year, maybe you guys, some of you have gotten away with just having great math ability and maybe a lackluster effort and still are doing well in this course or last year. That's not happening next year. To be successful in the honors course next year, you have to have, yes, math ability and a strong work ethic. That will lead you to succeed. It's not enough just to have a great math mind. It will not help you next year. You got to have both. Also, if you were good in Algebra 1, I hate to break this, it doesn't mean squat. Oh, I was good in Algebra 1 last year, so I'm going to be good in Algebra 2. It doesn't work that way. There's no relationship. All right? Bottom line is, if you want to take Algebra 2 next year, got to be somewhat decent in math and also have an outstanding work ethic. That is who I am going to recommend for Algebra 2 next year. The people who fall into that category. Now, if you end up taking Algebra 2 AB next year, let me make this very clear to everybody. If you are a 9th grader right now and you take Algebra 2 AB, you are still at 1 year ahead, 1 year accelerated. All right, just because we drop the BC and replace it with an AB doesn't mean you're going down a level or you're not accelerated anymore. No, you are going to still be accelerated if you are currently a ninth grader. So please keep that in your mind. Everyone thinks, oh, I'm taking AB. That's a step down. I'm not good enough. No, it doesn't. That just means you're going to be successful in that course versus if you took BC where you might not have been as successful. And it's not easier either. You guys can see here, it's still going to be tough material next year. Algebra 2 is a tough course no matter which one you take. And if you end up taking AB, you can still take calculus your senior year. Okay, you can still take calculus your senior year. So what's the difference between the two courses? Obviously, yes, honors is a heck of a lot tougher. The tests, quizzes, questions, everything's a heck of a lot tougher than AB, but AB is still a tough course. How am I going to recommend you guys when we talk in January or after we get back from break? I'm going to look at your grades. Yes, that's part of it, but I'm also, a big part of it's going to be your work ethic. I don't feel comfortable recommending lazy students to BC because I think they'll just sink right away. All right, so that's going to be part of it. When we get back from break, I don't know how I'm going to do this because usually in a typical year, I'd like to sit down with each and every one of you individually and have this discussion, what I want you to take next year and what your thoughts are. We'll figure out a way to do that, whether it be virtually or if we're back in hybrid mode, I'll do it in class. I don't know yet. Okay, but I do want to talk to every single one of you individually about my thoughts and your thoughts. But I just wanted to get these two courses in your mind right now. So you at least have over break to talk with you, talk to yourself, talk to your family, talk to friends who are taking honors algebra 2 and see what they think of the course. All right, but I wanted to get it into your mind, the two options you have for next year. Anybody have any questions about the courses that you want to ask now? Anything that I can answer? Sophia?
If you were to take honors algebra next year and you find this too difficult, would you be able to drop down during the year?
Absolutely. Yep. Mm-hmm. I would recommend dropping down, early as possible. You don't want to wait till midterms or after midterms to drop down because it may be a little bit too late. You're pretty much in the course by then. So if you do take that path, then I would recommend doing it as early as possible. Other questions? Okay, so something to think about. I'm not going to talk about it until we get back from break when we actually do recommendations, and I recommend you for a course. Now, and last thing, I'm going to recommend you what I think you're going to be successful for. I don't care what you think, what your friends think. I don't care what's going to be on a piece of paper for your transcript, whether it says BC or AB. My job for you guys is to recommend you for a math course next year, which I think you're going to be the most successful in. And that's exactly what I'm going to do. Okay? This isn't like, I don't want you to think about it as this is like cuts for a team or cuts for like the school play. It's not. If you're a ninth grader, you are still considered accelerated no matter if you take BC or AB next year. Okay? So keep that in mind. I want you to go to where you're going to be the most successful, not where you're going to look the coolest in front of your friends. Okay? So we'll talk about that after break. But if you guys have questions in the meantime, reach out to me. Okay? I'll tell you my thoughts ahead of time or if you don't want to wait. Okay? All right. So enough of courses for next year. We got to keep moving on in this quadrilateral unit. We spent a lot of time on the parallelogram, didn't we, last week? Algebra questions, 3 days of proofs dealing with the parallelogram. It is time to move down the family. All right, it is time to move down the family. And if you guys remember in your notes, I don't want you to go back, but in your notes in the family tree, we had the parallelogram on top. And then off of it, we had two figures. We had the rectangle and the rhombus. Those are the two figures we're going to focus on today, rectangle and rhombus. And their properties. Okay, their properties. Today is the algebra, tomorrow is the proofs. So let's start talking about the rectangle. If you guys read real quick, the properties of a rectangle, numbers 1 through E, 1A through E, it looked pretty darn familiar. Should look pretty darn familiar. Everyone go ahead, read A through E. Those are just what? Properties of a parallelogram. Don't forget that. Don't forget, just because I'm calling it a rectangle, it still has every single parallelogram property we discussed all last week. Don't forget that. All right, please don't forget that. That is still going to be huge, that a rectangle contains all the parallelogram properties. Plus a couple extra, which are only for a rectangle. Those extra are numbers 2 and 3. Number 2, they all have right angles. All of them have, I think you guys knew that, but every angle in a rectangle is a right angle. And here's something new for you. The diagonals, when I draw in diagonal DB and diagonal EAC, they are congruent to each other. In a rectangle, diagonals are equal. They are congruent. Any questions on those? Because I am actually going to, you guys are going to add in a 4th property right now. Property number 4 for me. Any questions? They all have right angles and the diagonals are congruent. All right, you guys find the 4th property for me, which deals with the diagonals. They're congruent, and somebody name me another property you already know about the diagonals of a rectangle, because it's a parallelogram. Here we go. We're going to start calling on people. All right, diagonals are congruent, and they do what? Diagonals are congruent, and they, here we go, 21. Zach, diagonals are congruent, and they also what?
Bisect each other.
Because it's a parallelogram. Good start, Zach. All right, so everyone think about this right now. The diagonals have the same length, and they cut each other in half. So my question is, what do you guys know about AE, EB, EC, and ED in my diagram? The diagonals are congruent, and they cut each other in half. So what should I know about all 4 of those pieces? 6, Caroline, what should I know about all 4 of those pieces then?
They're all equal.
Darn right. So everyone, AE equal to DE equal to EB equal to EC. That's not my property number 4. What type of triangles do I have right now? I have 4 what type of triangles right there now? Let's roll 20. Here we go, Radhika. What type of triangles do I have? 4 what?
Isosceles triangles.
There you go. So the property number 4, diagonals form four isosceles triangles. Diagonals form, and you guys just proved that. All right, why is that important? Sure. Why is that important? Because you guys know in an isosceles triangle, not only are the sides congruent, but the angles opposite, right? So if I take isosceles triangle AEB, I know for a fact those angles have to be equal. And I'm going to tell you that's going to be huge in the algebra problems we need to do. So keep that in mind. 4 isosceles triangles, so the angles across from the sides are equal to. Any questions, comments, concerns about our good old friend, the rectangle? Rectangle. All right, now move on to the rhombus. The rhombus. Oh, look at the first 5 properties of a rhombus, A through E. Where have we seen those? A rhombus has every single parallelogram property. Ooh. Okay, parallelogram property. Are you ready for the extras now? The extras for a rhombus. All sides equal. In a rhombus, all sides are congruent. I want to make sure it's clear before I move on. These are only for a rhombus. Do not mix them in with a rectangle. The properties we go over right now are only for a rhombus. So all sides are equal only in a rhombus. Diagonals bisect the angles. Here you go. Ready? Take a look. Here's what I mean. If I draw in one diagonal, I'll draw in diagonal DB. It is bisecting the angles, which means these pieces right here are equal, and these angles right here are equal. Diagonals cut the angles into two congruent parts. And the final property of a rhombus, if you draw both diagonals in, they will be perpendicular to each other, meaning they form a right angle at their intersection. Okay. Diagonals are perpendicular. All good? You ready to apply them now? Get those calculators fired up. Get your mind focused. Go ahead, question.
Oh yeah, which angles are congruent to each other in that? Are all of them congruent to each other?
Well, let's figure this out. It's already a parallelogram. So what do I know about opposite angles of a parallelogram?
They're congruent.
So if all of angle D and all of angle B are equal, and I cut each of them in half, shouldn't the halves be equal too? Right? So if D is 50 degrees and B is 50 degrees, I cut them. Each piece is 25, 25, 25, 25. So yes, all four of those are equal. Other concerns? Let's do this, kids. Number one, I am telling you right off the bat, I am giving you this figure's a parallelogram. I want a better name for it though. Based on the markings I put up there, I need a better name than parallelogram. So do you see an extra marking I put in there? Everyone see the right angle symbol I put in the bottom right-hand corner? So now this parallelogram I can call a parallelogram with the right angle. You can call 9. Here we go. Audrey, what can I call a parallelogram with the right angle?
A rectangle?
There you go. This is a rectangle. And I would like you to put just in parentheses why we're calling it a rectangle, because this will help with your proofs tomorrow. It is a parallelogram with one right angle. I don't need all four. All four right angles are not needed. I just need one right angle. That's it. If it's a parallelogram and it has at least one, I'm good to call it a rectangle. All right, now comes the tough part. We got to go back. Keep looking back. Keep looking back at your properties. I am not expecting you to know them down cold right now, right? But I am expecting you guys to keep going and looking back so you can answer these angle measurements. So 1, 2, 3, and 4. Don't go in order if you don't want to. Find a blank angle if it helps you. I'm just going to ask somebody what angle you want to find and just be able to back yourself up. So I started with the 18 up there. Keep going. What angle would you like to find first? Here we go. 17. Maeve, you're up. What angle do you want to find first, Maeve?
3.
All right, 3. You got it. What do you got for me?
18.
Why 18? Back yourself up.
All interior angles are congruent.
Okay, alternate interior. Now, I got a question for you, Maeve. You are correct. Alternate interior angles are congruent, but don't you need parallel lines for that?
Yes, and that's one of the properties of a rectangle.
Don't forget the parallelogram properties, all right? Don't forget about it. All right, yes, 18 and 18 are alternate interior. Good job, Maeve. All right, next angle you guys want to find. Use your properties. Maeve, up again, 17. You want to find another angle, Maeve.
I don't know. The angle that's like part of the right angle is like 72.
Okay, so the 18 you just found?
Yeah.
Okay, so now you're saying this is 72. Okay, I'm listening.
And then, I don't know anything else.
Yeah, you do. What was the property we wrote down about the diagonals of a rectangle form what? For what?
Isosceles triangle.
Okay, so this triangle on the right, Maeve, that contains angle 1 and 2.
72.
Say that again?
1 is 72.
Okay, everyone see that. I know angle 1 also has to be 72 because this triangle is isosceles. And across from the congruent sides are congruent angles. Hey, that's a property. Knowing the properties there. All right, so I got angle 3 and 1. Anybody going to go anywhere else? 18 now. Owen, you're up. What angle you want to try to find now? Got a lot of options.
Angle 4.
Okay, how do you want to find angle 4?
Using isosceles, so it would be 144 because it's a vertical angle.
Okay, which triangle are you saying? Which isosceles triangle are you using? The top or the bottom one here?
The top one.
Okay, so if that's 18, Owen's like, hey, this is 18. What's the missing angle, Owen?
144.
180 degrees in a triangle, and then it's what with angle 4? That 144, Owen, is what's its relationship with angle 4?
Vertical angles.
There you go. Vertical angles are congruent. Done. There's one way to get to it. Good job, Owen. And then angle 2 now. Jeez, you got your options here. If that's one, angle 4 is 144. You guys got your options here for angle 2. Let's hear from 20. Radhika, back to you. How about angle 2?
Can't you do vertical angles for this one too? Or actually, you could also just do 72 times 2 because angle 1 and like that, like the one where like the part of the right angle, that's also 72.
Yep.
And then you can subtract it from 180.
Yeah, that's one way. And what do you have there?
I have 36.
36 degrees. Got it. You could also say it's linear pair with the 144 next to it from angle 4. Yep. Okay, you guys have any questions for me there? Finding those. All right, let's go to 2 then. 2, it's a parallelogram already. Remember, it's a parallelogram, but now look what I marked. All 4 sides are equal now. So if I'm already in the parallelogram family and all 4 sides are equal, I can call this confidently, Quincy, here we go. What can I call this?
A square.
I don't have enough information we're not at a square yet because I don't know if they have a square is all sides congruent and all angles are right angles, and I don't know that.
Yeah.
But at least go ahead.
Did you already say there was a parallelogram? Or
That's what it's telling me at the beginning. Each parallelogram.
Okay.
So I don't have enough to say it's a square yet, but I can go in between the parallelogram and the square and say it's a what at least?
A rectangle?
Well, rectangle's got all 4 right angles. I don't know if it has right angles or not. All I know is all 4 sides are equal. What's the other figure we've already talked about today where all sides are equal? We talked about a rectangle, and what's the other figure we're talking about today?
I don't know. I'm kind of lost.
You got notes on you, or what have we been doing?
I have my notes here.
Okay, so we have a rectangle, and we've talked properties about a what? Page 22. We have properties of a rectangle, and then we have properties where we said all 4 sides were equal. We call that a
Rhombus.
All right, here we go. Called it a rhombus. All right, guys, a rhombus, here you go, is just a parallelogram. Now, I marked all 4 sides. You do not need that much information to call it a rhombus. All you need is 2 consecutive sides congruent. That's bare minimum what you need to say it's a rhombus. 2 consecutive sides congruent. You do not need all 4 to say rhombus. You just need 2 in a row. All right, so if everyone's got to go back in your notes, look at the properties. Because I'll let you know, just by looking at the properties, 3 out of these 4 angles are pretty darn easy. You guys don't need a calculator at all for this one. You should not need a calculator. All right, which angle do you want to start with? 18, here we go. Owen, back to you. Any angle you want to start with based on the properties of a rhombus?
Angle 2 and 3 are both 90 degrees.
All right, you took both of them right. Look at that, 90. Angle 2 is 90, angle 3 is 90. And Owen just looked back and said diagonals are perpendicular. That's all he did. Diagonals are perpendicular in a rhombus. All right, if those are 90, let me put my right angle symbols there. How about 1 and 4 now? Got to use another property. 5, here we go. Hayden, anything with angle 1 or 4?
Angle 1 is 59.
Yep. And you want to just explain why?
Because alternate interior angles are congruent.
Yep, angle 1, 59, because it's alternate interior with the 59 I gave you. Great job. And then how about angle 4 now? 17. Maeve, how about angle 4?
Also 59 because the diagonals bisect the angles.
Yep, that's a property of a rhombus. Diagonals bisect the angle. So the 59 I gave you and angle 4 are congruent. Done. No calculator needed, just plain old properties. Good job,
Even if
guys.
you forgot about,
What?
sorry, even if you forgot about the perpendicular part,
Yep.
couldn't you once you figured out that 1 and 4 or 59, you said that you said that all the angles are basically equal?
No, not all the angles are 59. Absolutely not. Just the ones opposite each other would be 59. But you would know, Sophia, that because it's a parallelogram, consecutive angles are supplementary. So you could add up the both 59, subtract it from 180, and then get that angle right there and divide by 2. That's still a way.
What I was thinking was that I had angle 1 as 59.
Angle 1 is 59. But what I'm saying is, like when I draw one diagonal in, that makes these two, all 4 of those equal. But when you draw the other diagonal in, then now you have a new set of congruent angles. All right, all 8 are not congruent to each other. All right. How about 3 now? 3. Ooh, well, geez. I did not give you guys any markings there, did I? I'm not really confident to say if it's a rectangle or a rhombus yet. I am not confident at all. But I do know it's a parallelogram. So can anybody tell me any of those angle measurements just by knowing it's a parallelogram? I'm not confident in saying it's a rectangle or a rhombus yet, but I can at least find a couple of those angles. Any angles you can find on your own. Let's go 3. Omni, any angles you can find on your own?
Yeah, angle 2 is 30 because alternate interior angles are equal.
There you go. Angle 2 is 30. Perfect. And that leads me right up. Go ahead.
Can't you use that to prove it as a rectangle because it has a right angle in it?
Now I'm getting to that. Yep. Now we know confidently angle 2 is 30 because it's alternate interior with the 30 I gave you. And now if you just heard what Omni said, hey, this 60 plus 30 adds up to be a right angle, which now makes it into a rectangle. Yep. I just needed that 30 because it was a parallelogram. So it's a rectangle because it's a parallelogram with a right angle. Good, Omni. Good. And remember, 1 right angle is all you need to say it's a rectangle. I do not need to know the other 3 are. All right, we know it's a rectangle now. You guys are up. Next angle you want to find. 5. Hayden, going back to you. Any other angles you want to find here?
Angle 4 is 30.
Angle 4 is 30. You want to just describe how you got to that?
Because it's a rectangle, it has 4 isosceles triangles.
Awesome. That's what I like to hear. So this is isosceles, which means across from the sides are congruent angles. Boom. Guys are rolling. Let's keep the train going. 15. Will, another angle you want to find.
Angle 3 is equal to 60 degrees.
Because
rectangles form isosceles triangles.
Yep. So if that's 60, that one's got to be 60. Or Will could have also said all right angles in a rectangle. So if that side's 30, that side's got to be 60 to make a right angle. Nice, Will. And then how about angle 1, everyone? Angle 1, 13. Sophia, what do you got for angle 1 for me?
It's also 60 because it's a parallelogram, so alternate interior angles.
There you go. Alternate interior. It's also a rectangle, so every angle's a right angle, and the one side was 30, other side's got to be 60. A lot of different ways. Good. I'm feeling more confident we're picking up our properties now. How about 4? 4 now. What figure is number 4 here? I got a parallelogram. 23. Here we go. Luke, parallelogram with all 4 sides equal. What is it?
A rhombus.
There you go. I can't stress this enough as we go into proofs tomorrow. You do not need to know all 4 sides are equal. It is good enough that it is a parallelogram with 2 consecutive sides congruent. All right. Okay, now that you know it's a rhombus, use your properties. Give me an angle you know. Give me an angle now. 7. St. John, give me an angle you want.
The measure of angle 2 is
68,
68.
yep. Angle 2, 68. Diagonals bisect the angles and opposite angles are equal. So all of these are, well, I don't want to say that yet, but that's 68, yep. Next, 21. Zach, give me another angle. Rhombus.
Angle 3 is 68.
Angle 3 is 68. Diagonals bisect the angle. Perfect. 68. Okay, another angle you want to give me. Let's roll 18. Owen, last one for you.
Angle 4 equals 90.
Diagonals perpendicular. Perfect. And then the last one I have is angle 1. A lot of different ways you can get to angle 1. When you're ready. 7. St. John, back to you when you're ready. Angle 1.
Angle 1 is 22 degrees.
22 degrees. A couple different ways. You could have said, I got a right angle there, and then there's 180 degrees in that top triangle. Good job, guys. Good job, everyone. Anything? Go.
I think it's that first one of 2 is 68, or angle 2 is 68, or
Did you get angle 3 first?
How did we get angle 2 was 68? Was that the question, or?
Yeah.
Okay, well, if this is, remember, let me go from the 68 I gave you at the bottom left-hand corner. That means the angle next to it is 68 degrees because diagonals bisect the angles. Now from there, you could say that 68 and angle 2 are alternate interior. So that's one way.
We've also done like something similar with like 68 and 3, the alternate.
Correct. Yep.
Then...
It bisects. You got it. You got it, Sophia. Yep. That's what's good about this. There's just not one way to get to the finale. All right, multiple ways. All right, enough about the angles. Let's talk about sides and diagonals now. So draw ourselves a picture here for number 5. A reminder, when you label a quadrilateral, we got to go clockwise or counterclockwise. Please do not jump diagonally or it'll throw the whole problem off. So H-I-J-K. H-J. Okay, so if I take a look, H-J is a diagonal. 3x plus 5. I-K. 5x minus 9. So I am giving you the values of both diagonals in a rectangle. Both diagonals in a rectangle. If you got to look back at your properties, please do so. Diagonals in a rectangle. Give me something from it. 25, going deep. Sabrina, what do we know about diagonals of a rectangle?
They're congruent.
That's it. Pretty easy problem when I know the property. 3x plus 5, same length as 5x minus 9. And then solve yourself some x. Woohoo! 2x equals 14. X equals 7. And just go back, reread the problem. Yes, find x, but also find the value of each diagonal. Which they should be equal, right? When we plug them back in. HJ is the same as IK. Go ahead, plug 7 back into either. You can plug them in back into both, but they should be the same value if we did this correctly. And we end up with 26. Length of 26. All good? Any issues, comments, concerns before we get to one last rhombus question? Let's do it. All right, so this is a rhombus. So I'm starting to review my rhombus properties again. GI is a diagonal, that's 8. FH is a diagonal, that's 6. Find a side. Question, does it matter which side we find? Is it going to matter? I see a lot of you guys shaking your head no. Why is it not going to matter which side I find for this one? Go ahead, somebody let me know. Go ahead, why? I'm not calling on anybody here. What do you got? Anybody just trying? Why doesn't it matter?
They're all congruent.
Rhombus, all sides are congruent. So you want to find FG, GH, HI, IF, doesn't matter. They're all the same. All right, let's go back to this diagonal business. GI is 8 and FH is 6. I really don't think that's going to help me get to a side. I really don't think that's going to help me knowing that the whole diagonal is 8 and the other whole one is 6. Keep looking back at your properties. Keep looking back. Tell me something about the diagonals of a rhombus. Keep going. Diagonals of a rhombus. Here we go, 19. Sean, anything else you know about diagonals of a rhombus that might help me in this problem?
Diagonals are perpendicular. They bisect the angles.
Okay, so let me start with your first comment, which is diagonals are perpendicular. So it forms at least some right triangles here, doesn't it, everyone? Forms right triangles. And then his second comment, yes, the diagonals bisect the angles. That is 100% true. I don't think I'll need that here because I'm actually talking about the lengths and not the angle measurements here. But that is a true property.
They also bisect each other.
Boom! Boom, right there. It's also a parallelogram. So the diagonals bisect each other. Watch this. If GI is 8, that must mean that this piece is 4, that piece is 4. If FH is 6, 3, and 3. I don't care which triangle you use, they're all the same. If you have a right triangle where you know 2 of the sides, how can we find the third? We've been using this bad boy all year long. Go ahead, anybody want to let me in on how can I find the third? Pythagorean theorem. Right triangle, no 2 sides, finding the third. 3 squared plus 4 squared equals the hypotenuse across from the right angle, c squared, which is my side. Yep. 9, 16, 25 equals c squared. And then, yes, we can take the square root of both sides. So one side looks like to be a length of 5. I don't know if you want to make a note or not, but yes, when you're dealing with diagonals of a rhombus, you will see a lot of Pythagorean theorem because this is the only figure where it's going to form right triangles. All right, so be ready for a lot of Pythag with a rhombus. All right, I'm done. You guys have any questions for me? You guys just have 24 and 25 for homework, those algebra problems. Everything on Classroom is updated. Assignment sheet updated. Homework answers for this week, all updated. All right, because I know we had the snow day last week, so that threw us off, but I redid the assignment sheet and everything's updated. All right, no quizzes or tests this week, not until the end of the week we get back from break. So just worry about putting max effort into your homework. That's all I ask this week. All right? Okay, reach out if you guys need anything, especially about courses for next year. If you have other questions or concerns, reach out to me. All right?
Actually, I have a question.
Sure.
So is Pythag, I kind of forget, is it only for right triangles?
Only for right triangles. That's it. Cannot be used on any other type of triangle. All right, guys. Have a great one. See you tomorrow.
Go wash your hands in your face. Do you have to teach here?
13, I do.
I need to get one.
Sorry. Back on 11:50 for math. Eating
It's
your
only 11:30.
no 11:30. No, it says 11 to 11:50. Lunch and recess. Eat, lunch, stretch, use the bathroom. Okay. And why don't we charge? No, just leave it there and I'll bring the charger up. Hello, Bear. How's your day going? Do we leave the lights on there?
I'll go check.
Get down, please. Daddy met in the bathroom, Claire. What? Bathroom. Okay, 12 o'clock. I have a serious meeting I have to be on.
Okay, while you're telling me, I'll be teaching. What are you doing? Five? Light. Turn the light up in the back.
Down at your dog, please. How was school this morning?
Good.
What did you learn about?
We don't learn about them in the morning.
What do you do in the morning?
We just do stuff. I'm like, I got the teddy bear one. I guess that's medical one. Can you put